Morning, kids. Today's class, we are going to discuss about the application of toppling problems. The application problems on the toppling we are going to discuss. So let me begin with this problem. So we have the like a block of mass m is placed on rough surface. It is acted upon by two horizontal forces. It is acted upon by two horizontal forces, F1 20 Newton, F2 6 Newton. Find whether the block will topple or not. So here we are, this is a block of mass m having the weight mg, 6 meter, the width. The height of this is around 10 meter, the total 10 meter. We apply two horizontal forces, one 20 Newton, other 6 Newton, and the surface is rough also. And quotient of friction given. We have to check it whether the block will topple or not. Altogether, the block will topple about, maybe it will topple about this point or this point. That has to be verified. Now let me start this one. The weight mg is acting. Let this be the center of mass. Okay, now how to verify that whether it topple or not. This is one major issue. As we know that the normal reaction will pass through the center of mass when these forces are not acting. When these forces are acting, then the normal reaction will shift. It will shift like this. Next question comes like, sir, on what basis you say that it will shift towards right? You have to check for the tendency of the block. If the block is having ability to rotate topple about point P, the normal reaction will shift and the maximum displacement of normal reaction will be 3 meters. If the block is having tendency to topple about this point, then the normal reaction from here which is acting will shift, will act here, will shift in this direction. Then it will topple about this particular point. How do we can decide? So look at this force F1, this F2, and the friction also will act. So it's all having a tendency to rotate about center of mass clockwise. So therefore, the block is having a tendency to topple about point P. So based on that assumption, so we are assuming that the normal reaction will shift like this, and will the shift, let it be x. Then you check the 20 Newton force, 6 Newton force, and this surface is there. What action the friction will act? We'll calculate the limiting friction. Mu mg. Mu is 0.8, 10 into 10. 80 Newton. So the frictional force will act towards left. And how much it is? 80 Newton. So what is the difference of these two? 20 minus 16. Definitely it will be only 14 Newton. So the friction will adjust itself to 14 Newton. And what is the state of block? Block will be at rest. Now we have to check whether it will topple or not. For that, I'll go for the net torque about center of mass. Well, torque set up by this force, applied force F1. This will be how much length? 3 meters. And this is 20 Newton. So the torque will be clockwise. Torque by the friction. You can check it here, like this will be 5 meters. And the friction force is acting. So this also torque by friction also will be clockwise. Torque due to weight will intersect axis of rotation, will not set up any torque. Torque due to applied force, F2 into this 1 meter, it will be anti-clockwise. Torque due to normal contact, this will be X, this will be N. This will be again anti-clockwise. I'll show it all the things here. It will be easy for it. This will be torque due to F1. Torque due to friction. torque due to F2, torque due to normal contact, are acting about the center of mass. Okay, fine. So now torque due to applied force should be clockwise. Torque due to friction will be clockwise. Torque due to applied force F2 and normal contact will be anti-clockwise. This will be F2. And the net torque will assume net torque to be 0. Then torque due to F1, torque due to friction, torque due to F1 clockwise, torque due to friction clockwise, torque due to F2 anti-clockwise, torque due to normal contact anti-clockwise, all set equal to 0. Torque due to applied force F1, this distance will be 3 meters. So this will be F1 into 3 clockwise. Torque due to friction, friction force into 5 meters will be clockwise. Torque due to applied force, F2 into 1 meter anti-clockwise. Torque due to normal contact, F1 equal to 20 into 3. Frictional force, 14 into 5. Applied force, 6 into 1. Normal contact, how much normal reaction? Should be equal to mg, 10 into 10, 100. 100 into, this will be minus 60, 76 plus 100x. Minus, or say 130 equal to 106. So x equal to 130 by 106. Some calculation error. 130 minus 6 will be 124. What is the conclusion? I got x equal to 1.24 meter. So therefore, what will happen to the block? The block will not topple. Okay, this will be our answer. Fine. Why it will not topple? As x is less than 3 meter. When the block will topple? When the block will topple? Only when x is greater than 3 meter. Because what is the maximum displacement of n? The maximum displacement of n can be 3 meter. So as x is less than 3 meters, so the block will not topple. Okay, kids, this is about the multiple forces acting. So we'll just analyze once. It will be easy for you. Okay, I have next one more problem. Here, a block of mass m is placed on a rough surface. It is acted upon by two forces, 20 Newton, 4 Newton. Find whether the block will topple. I think the same idea like earlier. We have to check it whether it will undergo toppling or not. Then we'll start the analysis like this. What is the applied force here? F1, 20 Newton. Here other force is 4 Newton. And we have the mass of the block 2 kg, this 0.2. Dimensions of the block given. This is 2 meters and this total height is 4 meters. Now first we'll start with the friction. Friction force Fl should be equal to mu mg 0.2 into 210. 4 Newton. Okay, fine. Okay, now the 4 Newton. So what is the applied force? The applied force is the applied force is 20 Newton and 4 Newton. I think definitely greater than friction. So the block, in fact, will accelerate. Will not be at rest, will be moving. So what is the condition of block? Block accelerates. No. So we'll check it whether it will topple or not. So about center of mass, okay, I'll assume the normal contact, let it act through this point. Here the limiting friction will act. Net torque about center of mass, we'll check it. Net torque about, so torque due to applied force. Torque due to the friction also. Torque due to normal contact is anti-clockwise. This is all everything center of mass. So net torque about center of mass 0. Now you have to ask question like, so why you are taking the shift towards right? We'll assume towards right because this particular force is greater, no? So definitely this force will try to topple the block about point P. So the possibility of N will shift towards right only. There's a maximum probability that net torque about center of mass should be 0. Torque due to applied force F1 into 2 meters. Torque due to this one 1 meter and this 4 Newton clockwise. Torque due to friction. This is 2 meter and this is, so here torque due to friction will be torque due to normal reaction. A torque due to applied force 20 into 2. Clockwise torque we take negative 1 plus F2 will be 4 minus 4. Frictional force 4 into 2. This also negative. Normal reaction. Normal reaction should balance weight. 2 into 10, 20 Newton. Minus 40, minus 4, minus 8. 20x is equal to 52 meter. X equal to 52 by 20. Definitely more than 2 meters. It is 52 by 20 will be 13 by 5. 2.6 meters. So x is greater than x equal to 2.6 meter, which is greater than 1 meter. What is the maximum permitted value of x? The maximum permitted value of x is 1 meter, no? Because the normal contact cannot act somewhere here. What is the maximum permitted shift of the normal contact? 1 meter only. So how much we are having? 2.6 meter. So definitely the block will topple. The x is 2.6 meter. The block will topple. if x were less than 1 meter, the block what happened would have not toppled. The normal contact cannot act here. Let me explain. The normal contact cannot act here. What is the maximum possible displacement of the normal contact, which is equal to 1 meter? At the most, it can act here. Since it is more than 1 meter, so definitely it will topple about point P. What is the conclusion? The block will topple about corner P. Okay, fine. These are some best ideas, sir. This is the point. Fine. So I hope students, I'm giving a better ideas. Please try to understand the concept. Writing this equation is the very, very, very important. You must learn the ability to write this torque equation. Rest all calculation. And you have to take a decision whether the block will topple about point P or about this point. How to decide that? By looking at the applied forces. If the block can, what are the possibilities? The block will not topple. The block will not topple. Or it can topple like this. It can topple about point P. Or it can topple about the left corner Q. So any one possibility. I assume that it will not topple, but it's toppling. But I got X positive, so it will topple about P. If X were negative, then it will topple about Q. Hope you are trying to understand. I assume that it will not topple. I got X 2.6. So what do you mean by positive plus 2.6 here? The block will topple about P. If I have got this as minus 2.6 meter, then the block will topple about Q. Like this, the analysis what we do. Fine. Let's take the next problem. Here we discuss a cone is kept here. A right circular cone, solid cone it is. A right circular cone of semi-vertex angle alpha. This angle is what is saying alpha, kept on rough inclined plane. I'm going to vary this theta gradually. Cone topples before it slides. Let h be the height of the cone. Okay, now I'm more interested how these angles are related. Theta and this mu are related. We'll start with the free body diagram. And the forces acting will be mg cos theta then the forces acting will be mg sin theta. Then the friction will act through this particular thing. Here the friction will act here. This is the center of mass of the cone. What is the total height of the cone? Total height of the cone is h is given, this h. So therefore, what should be the height of the cone? Center of mass of the cone will be h by 4. Solid cone h by 4. Hollow cone, if it were, it would have been h by 3. About what point it can topple? About point P. Then the normal reaction will act through this point. Let the base of the cone, let it be B by 2. Let H be the height of the cone and B be the base. Okay, we'll start the problem. Net torque about point P should be zero. Which all forces will set up a torque? Now torque due to mg sine theta will act like this. And we are getting this is h by 4. Huh? So torque will be torque due to normal reaction. It will intersect axis of rotation. Torque due to this will be zero. Torque due to friction. The friction also will intersect axis of rotation. This one. So torque due to this friction also will be zero about point P. So wall will set up torque. Torque will be only due to mg sine theta and this mg cos theta. So torque due to mg cos theta. This distance, perpendicular distance b by 2 and mg cos theta. Okay, this will be mg will get cancelled out. Tan theta h by 4. Okay, sine theta. Tan theta equal to 2b by h. Okay, what is alpha? Tan alpha by 2. Tan alpha by 2 should be equal to b by tan alpha by 2 equal b by 2h, or b in place of b, what we can write? Tan theta b by h will be 2 tan alpha by 2. So theta equal to tan inverse of 2 tan alpha by 2. Like this angle, if theta is greater than this particular value, the cone will topple about p. The cone will topple about p. If the theta is greater than this value, the cone will topple about p and it will fall off. This is one basic idea. So we can have any different shaped objects kept on inclined plane or on the ground. Only thing is, see, there are only two possibilities. Either it can topple about P or Q. These are the only 2 points are there about which it can topple. So if it can topple like this or topple like this, these are the basic conditions. Or topple out, it can tip. The angle of the inclination, if this theta greater than this, the cone will topple about P. So what we can write here? If theta greater than this value, the cone will topple about P. So we'll write here. If theta greater than I think 4 will come, no? Here b by h equal to tan alpha. 2 into 2, 4 will come. Okay, the cone will topple about P. Okay, then next question comes. So what will happen if theta less than this? It will not topple. Okay, then I'll say if theta is less than this value, like this, the cone will not topple, will stay on this one. Whether it will slide, whether the cone will slide or not will determine tan theta. If tan theta less than mu, cone will not slide. Tan theta greater than mu, cone slide down. Okay, agreed. Huh? These are the conditions. Huh? This is about condition for sliding. Huh? These are conditions for toppling. I think two different case situations here. Whether this cone will slide or will not slide will determine this theta and mu. Whether it will topple or not, this theta and alpha. Now we have a rectangular block is placed on a rough inclined plane. Find the angle of at which it topples on rough inclined plane. With the quotient of friction, let it be mu. Then what are the forces that will be acting? Weight mg. Mg cos theta. Then forces acting will be mg sin theta. Here mg cos theta. What about normal contact? The normal contact will act through this will take P and Q. Earlier it was a cone, no? Now we have brought the block. This is a rectangular block. So what is the condition for it to topple? Now the friction, how the friction? The friction should act up the incline. Okay, we'll write down the equations. Now net torque about point P should be 0. Try to make observation of this point. Net torque about point P should be 0. Okay, then based on this, mg sine theta h by 2 clockwise. Mg cos theta b by 2. The friction will intersect axis of rotation. Normal contact will intersect axis of rotation. Torque due to mg sin theta will act here. Torque due to mg cos theta will act like this. So this will be b by 2. This is a perpendicular distance. This is a torque. So torque due to mg cos theta will be clockwise. Huh? Will be clockwise. Torque due to mg sin theta will be anti-clockwise. The block will topple if torque due to mg sin theta greater than this. We are assuming like this. Huh? So minus, what's that, plus mg will get cancelled out. So sin theta h plus cos theta b equal to 0, or tan clockwise will assume negative, anti-clockwise will take positive. So therefore tan theta equal to bh. And if tan theta equal to mu, so we'll get a condition mu equal to bh. Okay, this is one basic condition. Irrespective of mass of block. When the block will topple, if mg sin theta greater than, if the torque due to mg sin theta is greater than mg cos theta, the block will topple, then tan theta should be greater than bh for the block to topple or vacuum. For the block, this is a condition. What about this? Like you wrote something here. This is about to topple. Then how mu and VH are related by this equation. Okay, now we are taking the toppling due to the centrifugal force. A cone of radius r, there is a cone of radius r and height h is kept on turntable. This is a turntable. And here we can call this is turntable. And this is a cone. This is a force. This everything is a turntable. Some rough diagram I'm showing it. Try to analyze. Then the distance between the axis of cone and the axis of turntable is r. Okay, this distance here is given. The maximum value of omega for which the cone does not topple. So it should not tilt. What are the forces they'll be acting? We'll analyze the forces. First, centrifugal force. Then next again, the normal contact. Afterwards, जो समुद्र है this is about the mg. Okay, these are the forces. Friction is sufficient. Okay, that friction will show like this. The arrow will show it. And this is mg. This is a normal contact. This is p, and this is centrifugal force. Mass of the cone is m. Then why the normal contact will shift here? The cone is having ability to topple about p. How do we can decide that? About center of mass, the torque due to centrifugal force and mg will be zero. The torque due to friction will be clockwise. Then tell me like who should balance if the cone doesn't topple? Then definitely the normal reaction will not act here. In fact, will shift and will act through this point. Since we are asking maximum, so therefore I'm assuming normal contact to be here. We are discussing just about to topple about P. Once again, I'm repeating about center of mass, torque due to centrifugal force, zero, because it will intersect axis of rotation. Torque due to weight will be zero, intersects axis of rotation. Torque due to friction will be clockwise. Then who will balance torque due to the friction? The torque due to normal contact. It should be like this. We'll show everything to the torque due to friction. Torque due to normal reaction. And rest all everything. Okay, these are the centrifugal forces like this. So the net torque about center, about point P should be zero. So, okay, now your task questions are what are these like? See, these are like a, either you can choose the, this one bits in, we wanted omega, no? We wanted omega. Therefore, why I'm showing all this torque due to normal contact and friction is to tell you that the normal contact will shift. If the normal contact doesn't shift, we'll assume that one. Normal contact will not shift. Let it act here only. Then will balance torque due to friction. Therefore, for that purpose, the normal reaction will shift. Will vanish. Let's come for all the things. So we'll go for these forces. We'll try to discuss about point. And is telling that this particular frictional force sufficient to balance this, to balance this one. So definitely what we can expect here, the with respect to rotating turntable, with respect to rotating turntable means you are standing somewhere here, or the state of the cone will be at rest. No, all will set up the talk about the point P. Centrifugal force. For a cone, what should be the side? H by 4. We'll indicate that in the diagram. And this distance will be R. We'll write down. Net torque about point P should be 0. Torque due to centrifugal force. Torque due to mg. Torque due to centrifugal force will be H by 4. Torque due to mg will be mg into R. We will simplify this. M will get cancelled out. So omega square H by 4 plus G. Omega is equal to if the angular velocity is greater than this, it will topple about point P. If the angular velocity is less than this, the block will not topple on the turntable. This will be your answer. Huh? A simple idea. So what is this m omega square r? It is about the centrifugal force. And what we are discussing, toppling due to centrifugal force. That's a basic idea of the problem. Huh? Now we'll take the next problem. Toppling due to the okay, kids. Now we have the problem related to toppling due to pseudo force. We are going to learn in this particular problem a toppling due to pseudo force. We are going to learn. Fine. So now there's a block of mass in. It is kept on an accelerating truck. All the height given. The height is 60 centimeters. The width is 15 centimeters. And the friction is sufficiently rough. And the mass of the block is 2 kg. Is asking to calculate this acceleration of truck. So what are the forces they'll be acting? First, we'll try to analyze the weight mg will be acting. Then how the pseudo force? The pseudo force will act in this direction. The pseudo force will be acting in this direction. Then about what point it can topple? It can topple about this point. Okay, fine. This will be the normal point. And the friction will act in this direction. So if you check it all, there's a truck accelerating. So the forces, I'll show it. There's a friction force. There's a weight and there's a normal reaction. There's a weight mg. The various forces I'm showing by the arrows. Now let's analyze all. This is mg. This is the pseudo force ma. There's a normal contact and there's a friction. There's a truck itself, and it is accelerating. This is the center of mass. This length will be w by 2. This is h by 2. So about what point it can topple? About p. It's having a tendency to topple about p. It's asking to get that minimum acceleration. So for minimum acceleration, so where the normal reaction must be, the normal reaction should act through the point P. For that, what's be the this particular pseudo force? Okay, now the net torque about point P go to 0. So what are the forces acting? Torque due to pseudo force, ma into h by 2. This will be clockwise, no? Then torque due to normal reaction will intersect axis of rotation. Torque due to friction will intersect axis of torque due to mg into w by 2. So is asking to get the acceleration. So this will be ah minus gw equal to 0. So this should be the acceleration of the truck. We'll substitute all the values. G10, W15, this will be 60. So 15 by 6. This will be 5 by 2. 2.5 meter per second square. If the acceleration of the truck is greater than or say greater than or equal to this, the block will topple about this point. How to decide it will topple about P? Why not about Q? So why can't some normal reaction be like this? We'll see like a now we'll check it about center of mass. We'll check the torque due to center of mass. Torque due to friction. I'll erase this. Time being no. Torque about center of mass due to friction will be anti-clockwise. Then torque due to the normal contact, if the normal contact acting here will also be like this, no? Then question of equilibrium not possible. So therefore the normal reaction must act at this particular point. And the block is about to topple about point P. Well, right here, the block okay, there's a question based on the block upon a block and the friction. There's one block here, there's another block is there. We are suspended here. First, we'll proceed like this. A block of mass 4 kg, height h. Height h. And breadth b. This is the height h and the breadth b. Based on rough, this is a rough of same mass m. And a string is passed over a pulley and a block is suspended. And a block of 1 kg is hung to the other end of the string. What will be the minimum value of coefficient of friction between the block and the plank so that there is no slipping between the block and the wedge? I think this will be the based on the first part. Everything will be based on the block upon a block concept. I like it. Next, find the minimum value of B by so that block does not topple over the plank. Friction is absent between the plank and the ground. Does not topple. So first we'll check what is the maximum force for no slipping. So here the tension T, weight mg. The tension should act away from the body. Normal reaction M. Weight mg. Weight mg. And the normal reaction here N, and this will be N dash. And this surface is rougher. The friction here should act on the upper block, the frictional force will act. No slipping should occur, so then the limiting friction will act. And the friction on this plank will be towards that. And this is smoother. So what is N? N is equal to mg. Fine. Then what is the maximum permitted limiting friction? Mu mg. Minimum value of mu is asking. Okay, let this accelerate. No slipping. Let there be acceleration. First, let me finish off this. I'll come back to the toppling condition. Then mg minus t equal to me. T minus f equal to me. F equal to capital M. Who will accelerate the block? Who will accelerate this plank, the friction? Who will accelerate the block? The tension here T and the friction. And as they're connected by common string, so both will have same acceleration. We'll simplify all the things. I'll add up all. Mg equal to M plus 2m into E. M is how much? 1 kg. So this will be 1 into 10. 1 plus 10 by 9 meter per second square. Okay, this value will substitute here. We know F equal to capital M. F equal to mu s mg equal to m. Mm get cancels. Mu s equal to A by G. A is how much? 10 by 9 by 10. This is your answer. Minimum quotient of friction. I think everyone knows block control. So now we'll go for the toppling. Now how to Bring the idea of the toppling. We'll discuss about the toppling ideas. So the second condition, the B, about the toppling. So the forces acting here, mg, this will be tension, this will be tension, here tension, here the weight mg will act, the weight mg, the friction. But what point it can topple and the friction on the upper block in this direction, on the plank in this direction. Then it should not topple. So what is the question? I was like, find the minimum value of B by H so that block does not topple. B by H. And there is a part. Okay, everyone able to see the question? What is the question like? Find the minimum value of B by H so that the plank friction happen between does not topple over the plank. Then shall we discuss this? Okay, let it have acceleration. Then here, with respect to plank, I'll discuss. The plank will also have acceleration. So the pseudo force will act like this. And the block is having ability to topple here. The normal reaction will choose in this direction. About point P, it can topple. First, we'll calculate overall the acceleration of system. So what is the acceleration of system? Mg minus P equal to Me. T minus F equal to Me. F equal to Me. Mg equal to M plus 2M into A. So A equal to Mg by M plus 2M. This will be G 1 plus 9 or the acceleration which is equal to G by then we'll apply the about net torque about point P. Torque due to the friction will be 0. I'll show it. The diagram looks a bit. It is on the block or we'll have one separate. The block itself I draw separately. The forces acting on it will be normal contact, the weight mg, pseudo force, the frictional force. Okay, these are the forces on the upper block. Mg, Ma, normal contact, and the friction. h by 2. Okay, now the net torque about point P, we'll check it. You see, like the torque due to the why we are shifting normal reaction towards it. So you do one thing, let normal reaction act here only, no problem. Then in that case, about this point, torque due to friction will be clockwise. Then who should balance, who should balance torque due to the friction that one. So torque due to friction will be clockwise, no? You can talk about the tension is also acting. I think. Normal reaction will shift towards right. No. No. Why it should shift towards, now about center of mass, check it. Torque due to pseudo force will intersect axis of rotation. Torque due to mg will intersect axis of rotation, and the torque due to and the normal reaction let it act, and the torque due to friction will be clockwise. Torque due to tension clockwise. Then who should balance this one? Definitely the normal reaction which is there should act here. Then the torque due to normal reaction will be anti-clockwise. So therefore, here it should shift. The normal reaction will act here. This is a block. We are discussing on the block. Okay, we'll write down all the possible equations. Let's talk about point P. Okay, we can calculate the tension also. After getting this acceleration, we can calculate the tension acting on this point. We need tension, no? First, let me calculate that also. Substituting this here, mg minus P equal to mg by 9. So tension should be equal to 8 mg by 9. And how much tension equal to 8 mg by 9. So this will be m equal to 1 kg. So 80 by 9 Newton it will come. Okay, let's go for the talk about this point. Let's talk about point P should be. I'll write down the equation. Talk about Q. Who all will set up the torque about Q. About Q we'll discuss. Torque due to friction will be 0. Torque due to pseudo force, torque due to mg, and torque due to tension will come. Torque due to normal contact also will be 0 because it will intersect axis of rotation. So the net torque about point P will be due to, about Q will be due to tension T into H clockwise, due to mg B by 2 anti-clockwise, due to pseudo force Ma into H by 2 anti-clockwise. So substitute all the values. Tension is how much? 8 mg by 9 H clockwise. M will be mg B by 2 anti-clockwise. Mg by 9 equal to G will get eliminated. M will be 1 kg. So minus 8 h by 9 4 b plus 4 h by 2 by 18 equal to 0. We have to get the ratio of h by n. Minus 8 by h minus 4. And simplify, 4 will get eliminated. Minus 2h by 9 plus h by 18 plus b equal to 0. We have to simplify for h by b. 9 I'll take common. H by 9 minus 2 plus 1 by 9. Calculation. This will be h by 9. 18 minus 17. 2 will come. So minus 4 by 3 minus 3 by 2. Minus h by 6 plus b equal to 0 is asking to get the value of h by b equal to 6. Okay, we have introduced torque due to tension also. I think this is the concept. Rest of everything is calculation part. Let me analyze. You can see the basic thing. This block will accelerate. This block and the plank are accelerating. Now it's asking us to, it should not topple. It is having ability to topple about Q. So therefore, the net torque about Q will define it. So the net torque about Q will be torque due to the tension, torque due to the pseudo force, torque due to the weight, where the normal contact and the friction will intersect axis of rotation. So we wrote this torque equation and solved it. But what about the tension? We don't know tension. How we calculated tension from the previous concept. No slipping will occur between the block and the plank. Already we have discussed same thing that I repeated here. Check it. Condition for no slipping, what's be the acceleration, minimum value of mu. When solving, we'll get the ratio as h by 6, b equal to 6. If h by b equal to 6, then the particular block, this block will not topple on the plank. Okay, this is one more last problem. A block of mass m1 is placed on plank of mass m2. Its surface rough. Find the condition in which block topples before sliding. So what is the condition? Like a conditions is asking directly. So what do you mean by conditions? Now, in what action the friction will act? Friction on this will act like this. Friction on the plank on the block will be in this direction. No, find the conditions at which block topples before sliding. First of all, we'll assume that before sliding or no slipping should occur. So what is the basic idea? no slipping should occur. So here we'll assume same acceleration. So what should be the acceleration? A is equal to F by M1 plus M2. The weight M1G. About what point it can topple here? We'll analyze through the plank frame. You stand on the plank frame. Then if you stand on the plank frame, then the pseudo force should act backward. Then the weight mg will act. About this point, about center of mass, we'll check the torque. If the normal reaction is acting like this, what the issue is like, the pseudo force will intersect the axis of rotation. This particular pseudo force will intersect this center of mass. The weight will intersect. The weight will intersect. The normal reaction will intersect. Then the friction will set up torque anti-clockwise. Then who should balance that one? So for that reason, the normal reaction, in fact, will not act here, will act at this point. And the normal reaction on the plank by the ground and dash. Agreed, everyone? Okay, now there's a point P I'm choosing. There's a Q. What all the toppling I should discuss about P, not about Q, because they're having a tendency to topple like this about P. Now we'll do one thing. For the maximum force for no slipping between the blocks, we'll start with this one. I'll discuss this separately first, then I'll come back to this one. Two blocks are there. We applied a force. What is the maximum force I should apply so that no slipping should occur? Then the friction here will be in this direction, friction like this. Then both will have same acceleration. Hope you recollect some block upon a block. Based on that, I'm analyzing. Then F minus small f equal to M2A. Adding up these two, M1 plus M2A. This acceleration is substitute here. F equal to M1 plus M2. Axle friction will be F by M1. As you increase the friction, as you increase applied force, friction force will also increase. What is the maximum permitted value of friction? When you apply this maximum force, the friction force acting between the blocks will be limiting. Then the maximum force for no slipping will be mu G M1 plus M2. I got this value of F. This was this F. Okay, now we'll calculate the acceleration. Acceleration will be F max by M1 plus M2. This should be equal to mu G. Okay, now you analyze only this particular thing. Talk about normal contact. The friction will intersect axis of rotation. The normal reaction will intersect axis of rotation. Torque due to pseudo force and the weight. Torque due to pseudo force will be anti-clockwise. Torque due to weight will be clockwise. Okay, fine. So this will be So torque due to net torque about P should be 0. M1A H by 2 will be anti-clockwise. Torque due to weight M1G B by 2 clockwise. AH minus, so what should be the acceleration? GB by HM. If the acceleration is greater than this, block will topple about P. Less than this will not topple. So I'll put a condition A greater than GB by H. Block M1 greater than or equal. Conditions at which is asking. What do you mean by conditions? What we should write here, what do you mean by conditions here? Look at this. This equation 1 is about the no slipping. And the equation 2 is about no toppling. I'll equate 1 equal to 2. Then I'll get mu equal to B by H. So this will determine whether block will topple or not. If this equation 2 greater than 1, the block will not topple before slipping. If equation 2 less than 1, the block will slip before toppling. And I'll let this. Okay, agreed. No? Means like whether block will topple or not will determine the value of mu quotient of friction B and H. Agreed. If mu less than B by H, it will slip before toppling. If mu greater than BH, it will topple before slipping. Okay, kids, like I will meet again with some higher level problems. Thank you for watching and my sharing my channel to most of your friends. Thanks a lot.